So how'd you feel about the test?
What's that?
How'd you feel about the test?
I did better than I thought I was gonna do. Well, I don't know, dude. That one was a lot harder than the first one.
Yeah, it was. I friggin' dropped my grade by like 4%.
Yeah, dropped mine like 7.
That's ridiculous.
Can you hear me? Or can you see me?
Yeah, I can see you.
Shiz. There we go. Okay.
In Stockholm, the team continues the investigation into the Codex's mysterious
You disappeared.
examine the Codex's particular portrayal of Satan, half-man, half-horned monster, with a lurid, forked red tongue and raised fists, dressed in ermine, often used as a symbol of supreme power. Those who believe the Franken legend must have imagined it was this beast who took the doomed scribe's soul.
Oh, there you are. Alright, sweet, let's do this thing. Can you hear me? Hello?
The Codex's artist or artists gave this archdemon a smell.
Alan?
Hello?
Rolled up inside a chamber of evil. No one has ever seen it. Alone. Stanford is working in London.
Oh, this is fun. I'm loving it.
He scrutinizes the Swedish library's digitized copy of the Codex.
What's extraordinary about this image is your traditional medieval image of the devil, which has the devil presiding over hell. It's not like this. This is the devil on his own.
It looks to no place as to who might have created such an unusual portrait. How Satan's depicted can reveal a great deal. A scribe's era, background, education, influences, and even psychology.
People felt very much they personified that threat to their continued existence very much as the devil. And it was the devil they worried about.
What was that?
Oh, dude. My wife was bringing the dishes in and dropped a knife on my foot. Oh, honey.
I'm sorry. I'm so sorry. Do you want the chicken stuff? Are you hungry?
No, I need to go to the ER.
Oh man, shame. Alright, you ready to knock this assignment out?
Yeah, let's do that. I have to, yeah.
You have to what?
I have another thing at 8 o'clock, so let's hammer, or 9 o'clock, so let's hammer this.
Alright, sweet.
Okay.
In a pie chart, why are the slices different sizes? Because they represent different categories and they're in different proportions.
Perfect. Bar charts are Pareto charts related, and Pareto's the only difference between a bar, largest to small, largest going left to right.
Agreed. Number 5, is P the true proportion or the sample proportion? P is the sample proportion, isn't it?
Let me look. I can't remember. P. Foot hurt.
I have categorical P hat is the sample. So
Sample.
P must be the true proportion.
This one would be the true proportion?
Yeah.
Okay.
Number 6, N is the sample size.
Okay.
If P is a quarter, what is the smallest N that satisfies the requirement? Frickin', I don't know. Time to look things up.
Hey, if I don't make it out of this video alive, know that it was my wife that killed me.
She dropping another knife on you?
Throws knives at me.
I don't even think it's by accident, man. I think you did something wrong.
I do too. You should see my foot.
I thought he'd never get the hint.
Okay, let's see.
No.
If P is a quarter and
Okay.
that's not Chandler, is it?
Chandler! Dylan says hi. I'm his companion from when we were 16. Yeah, he knows me. We grew up together. What the frick? Is he not remembering me? Oh, okay. I was gonna say, tell him Footsay, but don't tell him that.
Alright, anyways, I was looking up something.
I'm trying to figure this out too. Okay.
The central limit applies if both of the following conditions are satisfied: n times p greater than or equal to 10, n 1 minus p is greater than or equal to 10. So it would have to be what times 0.25 would be 10 or greater than 10. Let me see here.
40. If 40 equals,
So it'd be 40. Yeah.
okay, using the information for 8 and 9. Suppose that n is 24 and p is 0.04.
So what is the mean? 0.4. Standard deviation would be our I have the equation written down. P times 1 minus P, so 0.4 times 0.6 divided by 24 square root. So 0.1. So for standard deviation, I got 0.1, and for the mean, 0.4.
How did you? So for the standard deviation, I got 0.01.
Did you do the square root?
Oh, who? No, I didn't. Great job. Great job. Okay. 0.1, and you got 0.4 for the mean.
Yeah, because P hat equals P, so.
I love P hat. Okay. P hat equals P. So 10 is 0.3.
Yeah. So then we have 0.3 times 0.7 divided by 100. Square root. I got 0.046.
I got. That's exactly what I got. We must be doing the same thing.
So then our
Okay.
z-score should be our mean over our standard deviation.
What would be the value? So you do the value minus the mean.
That's what we're supposed to do, but I think we just have 0.3. Because we're doing, she will get more than 35 hits in her next 100 bats. So I think our z-score is just our 0.3 divided by our standard deviation.
Okay. Do you get Zora? Hey. Zora. Did you get 0.046 again?
Or I got that's in standard deviation.
I got that for the z-score too.
So your z-score is your mean divided by the standard deviation.
So isn't the mean?
So our mean is 0.3.
So the mean's 0.3, right?
Yeah.
So 0.3. Oh, dude, I'm an idiot. Okay, 0.3. Oh my heck. Okay, when I thought I was dividing it, I didn't put like. I was just putting the standard deviation.
Oh.
So you got 6.55.
6.522.
Really, I got 6.546.
So 0.3 divided by 0.0. What was it? 0.046. Yeah, 6.522. So you did 0.3 divided by 0.046?
Yeah, I was doing the whole. I wasn't rounding that to 3.
Oh.
Okay, and then what is the probability that Brittany gets at least 35 hits in her next 100 at bats?
Oh wow, that's a very low probability. 0.
0. Going off her recent stats, I'm gonna say not. Great. No, I'm just kidding.
Yeah.
I mean, hey, she got a good batting average, 300. That's decent. Let's see here. So if you're doing probability, wouldn't you just do 35 times 0.03? 0.3.
So no, because the probability you have to use the applet for that. You put in the z-score.
Okay. I need that. Okay, probability. I mean, I love Zora.
She loves you.
Okay. So what number you're putting in the Z?
Zeros.
You got zeros?
Yeah, because well, the percentage, the probability that it gives me is 6.93 to the negative 11.
Not cheap.
Are you putting 0.046 in the Z-score in the app?
No, because our z-score is 6.522.
Oh, dude, I am sorry. Okay. Oh wow, yeah, she's not hitting very good.
Nope.
That doesn't make any sense though, like, cause how would she have a 300 batting average?
Well, she has a .3 batting average. Brittany's batting average is .3.
Okay. Okay, so it's .000.
Yeah.
Okay, and then true proportion people who supported the politician candidate.
So the standard deviation is going to be point. All right. Divided by 2,000. Root. I got .011.
Or that's what I got. Okay, 0.01. Z-score.
So that's our mean. 6.2 divided by .011. Okay, there's no way that's right.
Did you get 46.55?
Yeah, that's weird.
Yeah, that's huge.
I think we have to take this getting less than 50%. So I think we have to take 0.5 minus 0.52.
Would that change?
I like that number a lot more. So that gave me a negative 1.818.
Where did you plug that 0.5 in at?
So I did 0.5 minus 0.52.
Okay, and then you divided that by.
Uh-huh. And then divided that by the 0.011.
Okay, so you got negative 1.790.
I got negative 1.818.
Ooh.
So you should have had negative 0.02
Yes.
divided by 0.011.
Oh, dude, I keep forgetting. So I haven't been doing it just to 3 decimals when I divide. That's why I keep getting them. I'm sorry, that's my bad. Okay, so. Okay. So your z-score is negative 1.818.
Uh-huh. They want to know the candidate suggests the candidate is losing the election. So then I think that's our probability z is less than or equal to z.
What probability do you compute using the normal probability act?
So on the applet, I got negative
0.069,
1.0691.
but then you're only doing less than 50%, right?
Yeah, so we just want the bottom half, so we divide that by 2.
0.0345. Okay. Okay, so on 16, it would be, it's smaller than the P.
So yeah, so I put P, what? PZ less than or equal to Z, because the probability is less than. I think.
Yeah, that one's hard.
Because we're trying to do if he gets less than 50% of the votes. So our P is our 0.52,
Okay.
and we're doing less than.
Less than the, okay, I agree. What is the probability of the survey results will show the candidate is losing even though the true...
So that one's 0.035, because that's what the applet showed.
Right, okay. I love the applet.
Oh man, what the frick?
How do you do?
We got a 78.
Shoot.
Yeah.
Ah, crap. On number 10, I only put one decimal place.
We got 10 wrong anyways.
No.
Because even though we put 0.3, it should have counted as right if we were right. Hey, look, we got that z-score wrong. I wonder what we were supposed to do for that z-score, because they just gave us 0.3 for both. Like,
Yeah.
I don't know.
Huh.
And then I wonder how come we got that z-score wrong, but we got the probability right on 15 and 17.
I don't know.
Oh, well.
Hey, and then on, so the final project overview,
Oh, yeah. We should probably look at that.
so we need to design the study this week, right?
Yeah, we have to design a study. The assignment is due on Saturday of week 8. That's this week, right? Yeah.
Yeah. Hey, and do you have time? So I'm gonna be, me and my wife are going to the LA Dodgers spring training
Uh-huh.
on Thursday and Friday.
Mm-hmm.
Do you have time to do the Thursday assignment tomorrow night?
Yeah, I have time.
Okay. Do Thursday's assignment tomorrow night, and then hopefully we can. Maybe we'll go about designing the study. Like we'll just kind of text each other, and
Okay.
then I'll update it on my computer and send or whatever.
All right.
Um,
So, let's see. For design the study, list of possible topics that you can choose from. So we have, are there 1,000 chips in every bag of Chips Ahoy?
I would certainly hope so.
Is there a difference in prices of books at BYU Idaho Bookstore compared to those available online?
Yeah.
Are men or women more likely to walk on the grass if they are walking behind someone who walks on the grass? What?
Interesting.
Are we allowed to like design our own study?
I think you have to choose one of these ones. Are the distribution of colors between plain and peanut M&Ms equal? If that means that I get to pick multiple bags of M&Ms, eat them. I'm down for that study.
Yeah, man, let's do that one. Let's just go each buy like 10 bags of M&Ms and then.
You're not helping my diet.
Yeah, it's not helping mine either, but I'm willing to pay the sacrifice.
I know. Come on, it's for an extent.
So to make sure we have the proper, sample size, we have to have at least 30. So we better each go get 15 bags of M&Ms.
Oh my goodness, that's a lot of M&Ms.
Yeah, it is. So I wonder if we should really do that, because that's like $15.
Maybe we'll do. Dude, let's do the. Are there 1,000 chips of chips and a Chips Ahoy?
Man, how in the world are we supposed to even count that many chips?
It has to be certain things.
Oh yeah, we'd have to do 30 things of Chips Ahoy. Dude, that can't be possible.
Yeah, I don't think we have to do 30 things, because we can just do the QQ test to make sure it's a...
Hey.
So do you want to do the Chips Ahoy or the M&Ms?
Almost.
Lady?
No.
Okay, then you didn't slice your finger open.
What? Almost
Do
did.
you want to cut my toe off? Is that how you're doing? She's having a rough night with knives. Okay, I say, I don't know. What do you want to do? The Chips Ahoy or the M&Ms?
I think the M&Ms will be easier.
Okay.
I don't want to count how many chips are in a bag of Chips Ahoy.
Sure.
So how many bags should we each get?
5.
5 bags each. All right.
Do you want to or do you want to like split them up equally between M&M and plain? Here's a better question. Are you a plain guy or an M&M guy?
I don't care, man. I do either one.
See, I'm an anything guy myself. So maybe we could do like 2 bags of peanut, 2 bags of plain each.
Yeah, that sounds good.
Okay. So that's 8 for the survey.
Yeah.
Or 4. Yeah, 8. I'm sorry. 8. Okay.
So let's just get those before tomorrow so we can just get data from each other already. And
Okay. And so we can count the colors and stuff.
yeah.
Okay.
Even though right now we're supposed to just be doing the design the study, but whatever.
Sure. Oh yeah, well he has to approve it, all right?
Yeah. So we better not buy anything yet.
Because I'll eat them without designing the study. That'll be bad. Okay.
I'm still gonna go buy some tonight, probably. I'm hungry now.
Good for you. Okay. Well, we can work on this tomorrow night too.
Yeah, that sounds good.
Okay. I'll see you then, dude.
All right, sounds good. See ya.